hey, every time I do a video comparing different sims, especially when there are updates, comments are heated, comments are emotional. Some people are very precise and differentiate, articulate. Some people are more straightforward, to say the least. And it always kind of gets me that people seem to have this notion that there is this easily accessible, measurable, real world out there, and that you just have to kind of take it, copy paste it into the sim, and then you're going to have the cars that drive like real world. And the question is, why do all sims feel so different then? Because we can be fairly certain that they all try to mimic real life as best as possible, and they are all reading the recent and most up-to-date papers on how to model certain things in the game. But we have different games in the end, so perhaps it is not actually that easy. So in this video, I really want to talk about a bit about the challenges of making a sim racing title, and perhaps afterwards we can all sit back a little, relax, and not be too emotional about to find the right sim, the sim that does it all correct, the sim that is entirely wrong, because there are much more nuances to it. And it kind of can also mean that 2 sims or 3 sims or all of them can be right and wrong at the same time, despite feeling entirely different and doing things entirely different. For this video then, I think I want to mainly talk about physics because yes, we know, of course, there are different graphic engines, the game will look different, and there's going to be different efficiency in different engines, and some will run with higher graphic settings, look prettier, while producing more frames, and others won't. But this is not the main concern and what usually kind of produces the biggest arguments in the comments. So we want to focus on the physics stuff, and there are certainly things that are easier to access. They are easier to find in the scientific literature. Some things are very clear, and there will be things that are not so clear. So first, let's kind of agree on that the basic laws of physics, they are well understood in society, and this is something that sim racing developers can just kind of tap into and put into the framework that they have decided to produce for their sim racing title. So I'm fairly sure that at least in all the situations that we are supposed to experience in the sim racing title, the basic laws of physics will be correct. But there are also things where things get a little more vague and where assessment is a little more difficult. And this is, I think, where things start to differentiate and where and why sims start to feel different. It's probably impossible to kind of conclusively discuss this everything, but I want to give a few pointers at least and give you an idea of what to think about and why it might be difficult to assess real life and measure the real thing, and why there might actually be a bit of room as to what the real data can show, and that it's never this kind of pinpoint thing and then you just take it to the game and you're set. Just think of the situation where it's really expensive to run real cars on a racetrack, especially when you're considering race cars, not road cars. So you probably need a team of engineers that brings the car. You need to talk to the manufacturer or the racing team running the cars. And very quickly, you're running into pretty significant dollars, euros, whatever, to conduct a single test. So what you'll most likely do is try to get data from the teams as much as they're willing to share. This is probably also not something that they're very comfortable with, or they give you restrictions, or they give you a standardized data set that isn't necessarily from a specific track day or something. So let's assume you are on a track day and you're getting the direct access to the data and the team is really open. Then probably you can't conduct all your tests in a single day. You probably need several days. And just in that example already, I want to kind of highlight a few things. Say you start on a Saturday morning, the track hasn't been used for a week or longer, it has rained in the meantime, there has been a bit of dust being collected on the track, so the Saturday morning session is going to have a certain grip limit, right? You you might have a very experienced driver, he already knows the track, but still he might be just ever so slightly rusty in the first couple of runs, not produce the good lap times or whatever. Then you get your data set and you get your G-forces you have in the corner. You measure the temperatures on the tire that develop. You kind of feel from or get information from the sensors, how the car moves on the tires, how the yaw angle looks, and what the input is, how the car responds, and all that. And then you kind of wait for a day, other cars are driving, perhaps with different tire manufacturers, they lay rubber down, and you go back onto the track on a Sunday, and now you're suddenly driving on a rubbered in track, perhaps on a different rubber. And sometimes you have the situation that the rubber you are running on your car doesn't necessarily work very well with a rubber laid down from a different tire manufacturer. Or you had different support series run in the meantime that also change how the track behaves. And suddenly, when taking the same driver with the same car with the same fuel load on just a different day, your data all of a sudden looks different. And there are just so many factors in real life that you kind of have to account for that in the end it becomes kind of impossible to measure and kind of weigh and balance how much of an influence these different factors have. And the problem you get from that in the end is that you kind of have data points that have a bit of a range of being correct. So the typical stuff in science is that you have a data point and you have a 95% confidence that the correct result is within or around that point with a 5% margin up and down. And pretty much the same thing then needs to be true for the sim racing games or the sim racing developers and where they draw their data from, because the situation IRL is simply not the same 2 sessions in a row. Might be the tire set, might be the driver a tiny bit tired, might be the car setup ever so slightly changing, might be somewhere on any car component, might be a bit of a wind blown in some of the corner, and or just a leaf under the tire and just giving you a different impression in that data set. And of course you can't run endless laps to have, say, 1,000 laps so you can average out all the mistakes and stuff like that. So you end up with likely values. And I think this is kind of the first point where all the major sims will differ a bit, because the environment in which they're testing, the environment in which they have access, the teams they have access to, the manufacturers they have access to, the data they have access to, in the end will differ. With iRacing's origin, for example, coming from NASCAR, they will have good connections there and good access to these kind of teams, and they might be able to assess tires from there and get a lot of data from these teams. Whereas Kuno's based in Europe and Italy now with SRO doing the official game, they have better access to GT3 teams, at least to those who are willing to share data, and the manufacturers of the GT3s that we have in the game. Then also Pirelli is producing the tires for the GT World Challenge game that we have, so naturally they will be talking to Pirelli, replicating a Pirelli tire. And I think people forget that not necessarily every tire drives the same, and I feel this is like an extremely understated and overlooked fact that different game developers might be, or will certainly be, trying to mimic tire behavior of completely different manufacturers. They have a data set based on completely different tires of different cars ran in different conditions on different tracks in different weather. So it is very tricky to say that, well, iRacing has assessed their, I'm just kind of making this up, all right, but iRacing gets their big fundament, perhaps. I'm just extrapolating here. It could be anything else, but just kind of trying to point out the difference. But iRacing has a big base in the NASCAR department, and nothing there is necessarily wrong, but does it carry over to when you kind of conduct the same test on a Pirelli tire on a GT3 in Europe in largely different weather conditions, different tire, track state, driver, and these sort of things? So what I really just want to say here is that all of these sim developer studios and where they get their data from and how they implement them and try to recreate this data in the game, they might all be correct in what they do. The problem they have is where the data is coming from and in which situation it was created. And even if they are 100% accurate and replicating the data they have, the problem is that we never really have this one correct assessment of real life, because real life is so extremely dynamic that you never really know what is supposed to be your standard condition in a game. Another problem often is, and I kind of already touched on it, is you don't necessarily get the amount of data you need. Sometimes you have to live with rather small samples, or manufacturers are not actually sharing the data. Sometimes you have to draw things from very different sources than the manufacturer or the teams, and building a car in a sim often might just be some sort of a puzzle where you try to draw information from various sources that end up being your full car. Because you have to see that not every manufacturer will have someone readily available sitting at a telephone waiting for the call from a sim racing developer, asking them if they could share the data set of their latest car creation, because the focus, of course, in these companies is way different, especially in GT3s. What they're trying to do is get these cars working on the road, get them to sell to customer teams, and their main focus is not necessarily the sim racing audience, who very unlikely will ever buy a GT3. So, of course, this kind of shuffles down the order of importance, and thus you don't necessarily get like, here's a complete data set of our car. We're going to share everything with you. What do you need? Let me actually call you tomorrow. I'll give you all the data. This is most likely not the case. It's probably very tricky for sim developers to actually get close with a team, gain their trust, and get huge insight in the data. Another factor is, and Ara spoke about this in the past, of course, maybe some part of that might be an excuse, some part might be true, is that some teams are really not willing to share data going too deep, because the more detailed the game is, the more easy it is for competitors to actually just look in the game and learn something about your car, which is something you want to keep a secret to keep the competitive advantage. So my point here is, you sometimes face a major lack of data as well, on top of already having kind of a vague data set where you not really know, is kind of this data point correct? Is this data point correct? Or is it somewhere in the middle? Now, once let's say you have that gathering of data sorted, and you've decided what is actually like the target behavior you want to replicate in your game, then it's about to decide, how do you actually do that? What is the framework where you're going to put that in, or what's the framework how you're going to recreate that data? And in sim racing, there are like two big methods, so to say. It's probably not as clear cut that some sims are on one end of the spectrum and the other sims are on the other end of the spectrum. There is probably going to be overlap between these two measures, and I guess the common term for this is we have the physical tire model versus the empirical tire model. And I just really want to touch on this only very rudimentarily and quickly, because it probably going too far, and also I simply don't know enough about it, because I can't just look in the game and how people do that. It's just not laying there, so to say, but we have a bit of information that we can talk about. Let's start with rFactor 2, because rFactor 2 actually allows us a good kind of insight into what they're doing in their game. It is open for developers or modders, and they provide a toolkit for these modders to actually produce the cars in the game. Part of that is the so-called tire trainer, which allows the developers of mods to produce a tire that they want to use on their modded car. What you do in that trainer is essentially, and I will link a paper below where someone really describes all the detail about that, even difficulties and challenges you're facing using that. So we're going to keep it superficial here, because that paper goes into a lot of detail, and if you care for that, it's linked below. You enter all the properties of the tire that you want to simulate in the game. So all the dimensions, rubber properties, and whatever that thing provides, right? You can go into a lot of detail there. And what the tire trainer then does is essentially it's putting the tire through thousands and thousands and more different driving situations, and in the end is producing, so to say, grip values for each combination of potential tire situations. So it's going to consider the tire pressure, it's going to consider the tire load, temperature, slip angles, and whatever you can think of, really. And for a combination of all these values, there will be an according group value. And all this is put in a 5, 6, 7, or 10-dimensional file that becomes the tire in the game. So what the game can then pretty easily do when you are playing is it is just looking at what are all these outside values of the tire, what's the pressure, temperature, load, etc. And then it goes to this table and looks up what the according group value is. This is, of course, a simplified way of saying this, okay? It's more complex and probably goes beyond my head, but I'm just trying to get it across to you what is happening. So you drive along the track, you go through a corner, and a couple hundred times per second, the game will look into this table and kind of report back, this is the grip value you should be having now on this tire, gives you that grip, and this is how the car drives around the track. And this is what generally is called the physical model, as the tire is physically recreated, then put on the testing stand, and all the grip values are recreated. And then you have, so to say, this big table where the game is trying to look up and get back the grip value for every possible situation a tire can be in. Then we have this other approach, which I got from conversations I did with Aris when we were doing an interview for the magazine we wrote for VCO, where he explained a bit how it works in ACC, and ACC is following the empirical model approach. And what they do there is they have all the formulas that are in the tire trainer, so to say, they have them live in the game. So every, well, not every, but several hundred times a second in ACC, the tire is being recalculated, and the formulas and the calculations, they will return a grip value. In ACC, there is much less looking up in the table, so to say. There's rather a combination of tables that is happening. But the difference is that ACC does not have the problem of having to run through the tire trainer each time they're trying to change something on their tire model. So when Aris was getting a bit more open in this interview, thankfully, he was sharing that he has the option to very quickly go into his tire model, so to say, change a bit of a couple parameters in that, put it into the game, start it, and do very quickly a test with new physics, so to say. And this is much more difficult for rFactor 2 in this instance, where they first have to run the tire trainer again, produce a new table for a variety of different tire situations, put that back into the game, relaunch the game, and test it. And this is a much more time-consuming approach because you have to wait for the tire trainer to produce the file, which, as I said earlier, depending on your hardware, can take up to hours or days. This also explains a bit why different simulations have different limits as to how fast or how often they can calculate things. Just imagine when the game only, and this is all a huge simplification of the thing that is actually happening. But if your game solely has to look up in a file what the actual grip value is, given all the other values that the tire currently has in terms of temperature, pressure, etc., then you can do this maybe 1,000 times per second or 2,000 times per second without running into computational limits. However, if you're calculating a lot on the fly, then perhaps this calculation is more CPU consuming and it puts you into different limitations, and then you could only run lower frequencies in terms of physics. Could be 60, 100, 200. Depends if you're running your game on a console, if you're only having PC, if your minimum specs for that game are going to be X or Y, and that sort of thing. So this is why we also see different frequencies in terms of physics calculations in the different games. And of course, if you are running into limits in terms of what you can handle from a computational perspective, then perhaps you also have to make other things in your model to make this process more efficient. So initially, ACC just had a 1-point contact model, and later they found a way to choose a 5-point contact model because they were able to make the process efficient enough to handle much more data points, assessing where the tire is on track and take calculations from there. Another big factor for sim racing developers, of course, is talking to real drivers and engineers, but let's focus on the drivers here a little. Most real life drivers, and probably the older they are, the more experienced they are, the less they will have been in touch with sim racing titles. Not everybody is Tony Kanaan, who is just embracing sim racing as he does. Most of them are probably far more distant to that, and some might have only really driven the kind of official sims of the big teams, and they indeed might be quite a bit different to what we have in the game. I had the chance to drive a few of them, actually. There's a video on the BMW channels, indeed, where I was driving in the official BMW simulator together with Bruno Spengler, former DDM champion, and Max Benecke, some sim champion. And that revealed really how different that can feel. And in the grand scheme of things, when you are talking to real life drivers, you of course are going to have an issue with the feedback you're getting, because all of a sudden you have a situation where one driver tells you one thing, another driver tells you another thing about the kind of same situation you were asking them, because they might be in a different car, they might be running a different setup, they might just simply have a different place where they're coming from. Some might have started with the karting and they went through Formula One, or they were motorcyclists and they are now driving a GT3 car, and all their experiences will be a little different, and the way they describe things might be different, and finding a common language between a sim developer and a racing driver is probably some of the more difficult tasks, because I can already see this when we are talking in the comments. People using different words for the same thing, or people are using same words for different things, and the conversation about this whole physics and behavioral and the car feedback stuff becomes really, really tricky, and there's a big room for interpretation of things that it becomes really tricky to understand the feedback and then convert it into a certain feeling the car is giving the player. So when iRacing, again, they have a good foundation in the NASCAR or maybe in US-based series and to US drivers, and they might all be driving on Firestone tires or whatever they have available. They are simply going to have a different experience what real-life cars behave like, what real-life tires behave like, and they're going to report back different feedback to iRacing than European GT3 drivers are reporting back to Kunos when they are driving on Pirelli drivers with whatever cars they are driving, right? So I just want to say, everything that we've talked about in this video, assessing the data, measuring the data, getting hold of data, defining what a standard condition is, talking to real-life drivers and getting feedback, all of this is more of a range of possible realities. There isn't this one clear-cut point that you can call reality and that you need to recreate. So coming back to the beginning, when I said that when comparing different games, there's always this huge amount of comments that are getting very emotional. I get it. We should, in the future, at least on this channel, hopefully, keep in mind that all sim racing developers, they are genuinely trying to do their best given the resources they have, given the access they have, given the team size they have, given the data they are provided, given the access to drivers they have, given the feedback they are receiving, given the tire manufacturers they are cooperating with, and all the things that they do and have is in the end going to be reflected in the game. And as I said, there is a huge variety in what a certain car does in a certain situation, and you can't really put a finger on it as clearly as some people I think might expect this to be possible. So what we're getting is, in sim racing games, we are getting a variety of likely realistic representations of real life racing in the games. This also means they are probably all correct one way or another, but they might be different at a different point in the spectrum, whereas another game is on the other end of the possible spectrum. And both is within the scope of a realistic representation, not necessarily wrong. And my kind of impression is that over time, sim racing titles are getting more similar to one another, which means we are narrowing down this range of a potential reality that all these games are trying to mimic. And let's kind of just think forward 20, 30 years or so, maybe this range is even getting smaller and we're getting much closer to this actual point. But I think it will never be this one point where all the games feel the same, because in the end they have different tires, they have different cars, they will have different feedback, they have different realities they are trying to mimic in the game. So all of these different assessments of reality kind of have a credibility to it, and I wish we could just keep that in mind in the future when we're discussing games, when we're discussing the updates, that at least to assume that they're all trying their best is probably the fairest you can do, and that their reality they're assessing and the reality they are recreating might be indeed very different ones, and that is in the end why the Sims we play are going to feel different. Maybe perhaps one day I'll get the chance to drive a real car and can go deeper on the topic and share my biased feedback in the very situation I've been driving the car in, with a certain tire manufacturer, certain car manufacturer, certain car setup and weather and whatever was driving on that track that day or the day before, or the torrential rain that came down and washed away all that rubber, which will influence that experience. But for now, I think we should leave more room as to what real physics really means, real behavior really means, because it is not necessarily this one correct behavior that is just out there and needs to be taken and put into the game, because the variety of experiences in real life is different. And that is what we're seeing in the games.